Hi everyone, welcome back to our channel. So today we are going to solve problem number 30. So the question asked is, for the given network, find the current through 5 ohm resistor by using the principle of superposition. So this is very simple to understand. So before applying the position of superposition, let's try to understand what is the concept of superposition theorem. So what is the statement of superposition theorem is, if a number of voltage sources, so this may be one voltage source, if a number of voltage source or current source are acting at a time or simultaneously in a linear network, the total current is I dash plus I double dash. So I dash is obtained by activating 10-volt source and deactivating 1 ampere source. We have to make this 1 ampere source as open circuited, and we want to find out the current in the branch RL ohms. Similarly, so here 10 second process is you try to activate this and deactivate this. So second process is you activate 1 ampere source. So 1 ampere source is activated and this 10-volt source is made as deactivated where V equal to 0, and find the current in the same RL branch. This is called I dash plus I double dash. This way of adding the current by activating 10-volt source and by deactivating 1 ampere source, and by activating by deactivating 10-volt source and by activating 1 ampere source. This process is called superpositioning. Okay, so this process is called superpositioning. Already this is one position, we are activating it and we are deactivating it, and later we are activating it and we are deactivating. The positions are increased, so there is an increment of positions. Okay, the positions are increased. So whenever the positions are increased, then this is called as supering, or this is called the process called super. That's why name of this theorem is called superpositions. Means more positions are available in this theorem. Okay. Now let's try to do this problem. So coming to the solution for this problem. So you see here now, as the process I told, I want to find out current I equal to I dash plus I double dash. So now I'm going to find out I dash. How to find out I dash? So I want to find out the current in this branch. First activate 10-volt source. So 10-volt source is activated and 1 ampere source is deactivated. Okay, so deactivated means we want to replace this 1 ampere source with an open circuit. Okay, now see the problem. So this 10-volt source is active and this 1 ampere source is open circuited. This is the meaning of deactivation, and already we are having a load resistor as shown in the problem. So this is nothing but how much? 5 ohm. So now the current flowing in this branch is nothing but IL dash. So now from here, so what is the current which is flowing in this branch is IL dash. So you can see the current how it flows. So this is the direction of IL dash. It is flowing in this process. Okay, IL dash is equal to I equal to, formula is V by R. So what is the voltage at this point? The voltage at this point is 10 volts. The voltage at this point is 0 volts. How to write down V? 10 minus 0, which is nothing but 10 volts minus 0 volts divided by R. So what is the R value? R is just only 5. So 5 ones are 5 twos are, which is nothing but 2 amperes current. So flowing from top to bottom. So in this direction the current is flowing. So which indicates that this is flowing in a counter clockwise direction. So similarly, second step we are going to find out is, we are going to find out I double dash. So here we have been find I dash. Now we are going to find out I double dash. So in this already I told we need to short circuit the voltage source and make this V equal to 0. And now current source in active state. Okay. So this is the current source we are having and this is in active state. And we need to find out the current in this branch. So the resistance is how much? 5 ohm. So I need to find out the current which is flowing in this branch, which is nothing but IL double dash. So already I told that. So Actually the current 1 ampere will come to this point, and this branch is offering high resistance, and this branch is offering low resistance. Why? Because 0 ohm. So okay, so current all the time will flow current I equal to V by R. So wherever the resistance is low, only in this direction the current will flow. Therefore the total current of 1 ampere will flow in this direction. It doesn't flows across this 5 ohm. Since the current is not flowing, I can say the current in this branch is how much? 0. Therefore the current in this branch is 0. So from here I'm going to get IL double dash is equal to 0. Okay, so as per the superposition theorem, the load current IL is equal to IL dash and IL double dash, and this current is also flowing from top to bottom, where this is nothing but counter clockwise direction. This is also counterclockwise direction, this is also counterclockwise direction. Therefore we are going to get the sum. So the current is 2 ampere plus 0 ampere. The total current in the load resistance is how much? 2 amperes only. Okay, so this is how the current is flowing across the load resistance of 5 ohm. Hope you are able to understand. So initially activate the source and deactivate the source, and then activate the source and deactivate the source, and find out the currents I dash and I double dash. This concept is called the concept of superpositioning. Okay, statement is if a number of voltage source and current sources are connected acting it simultaneously at a time, so find out the response I dash by activating one source and deactivating one source, and activate another source and deactivate the another source. This process is called superpositioning. That's why name of this theorem is called superposition theorem. Hope you understood the problem well. If you feel the explanation is good, please like the video and kindly subscribe to the channel for more updates on the channel. Still, if you have any doubts, let me know in the comment section. I can answer your questions. So if you're watching the channel for the first time, subscribe to my channel with the name KV Tulasiram. Yours obediently Ram.